Welcome to Data Engineering Studies YouTube channel. In this video, we are going to see an overview of Spark. We are going to see some of the big data concepts. At a high level, we will see what is Hadoop, what is Mapreduce, and what is Spark, and how Spark is different from Mapreduce, and why we are using Python along with Spark, and some high-level details about SpiceSpark. Spark uses a distributed system to distribute the data across many machines. So what is a distributed system? How distributed system is different from the local system? Local system uses the computational resource of a single machine, whereas a distributed system has one master node and many worker node. A distributed machine distributes the data across multiple machines. It is easy to scale out to many low CPU machines than try to scale up with single machine with high CPU. It also includes fault tolerance, where it replicates the same data across multiple machines. If one machine goes down, the network can still go on. Hadoop uses something called HDFS, Hadoop Distributed File System, to work with a large dataset. Hadoop also duplicates the data for fault tolerance. So if one machine goes down, the data will be still in the other machines, so there will not be any loss of data. Hadoop also uses Mapreduce to perform computation on the distributed data. So Hadoop has fundamentally two components, HDFS and Mapreduce. HDFS is to distribute the data across multiple machines, and Mapreduce is to perform computational operation in the distributed dataset. Mapreduce consists of a single job tracker and multiple task trackers. Job tracker sends the code to run on multiple task trackers. The task tracker allows CPU and memory for the tasks and runs the task on the worker nodes. Spark improves on the concept of the distribution. Now let's see the overview of Spark, Spark versus Mapreduce, Spark RDDs, and Spark data frames. Spark is one of the latest technology being used to handle big data. It is one of the open source project in Apache. It is created at AM Labs at UC Berkeley, and it performs operations 100 times faster than Mapreduce. Now let's see some of the key differences between Hadoop Mapreduce and Apache Spark. Apache Spark is 100 times faster than Mapreduce. How does Apache Spark achieve this speed? Hadoop Mapreduce stores the data in the disk, whereas Apache Spark stores the data in memory, which is in the RAM. Storing the data in memory is much faster than storing the data in disk for processing. Hadoop Mapreduce is good for batch processing, whereas Apache Spark is good for real-time processing. Batch processing is like if you get the data from a source on a scheduled interval, whereas Apache Spark is good for real-time processing. Real-time processing, in other words, we can call it as streaming data. Hadoop Mapreduce is written in Java, whereas Apache Spark is written in Scala. Now let's see what is RDD. RDDs are resilient distributed dataset, which is the main logical data unit in Spark. They are distributed collection of objects which are stored in memory of different machines of a cluster. As the name suggests, RDDs are resilient. RDDs track data lineage information to recover loss of data automatically on failure. This is also called fault tolerance. RDDs are distributed. That means that data present in RDD resides on multiple nodes. Spark performs two types of operations. One is transformation and action, which we will see in detail in my next video. RDDs does lazy evaluation. That means that transformations are actually computed when an action is called. RDDs are immutable. That means that data stored in the RDD is read-only. You cannot edit the data present in the RDD. RDDs perform in-memory computation. That means that RDD store the immediate data in the RAM than on the hard disk, so that it provides faster access. A single RDD can be divided into multiple partitions so that these partitions can be stored and processed in different machines. Now let's see what is Spark data frame. Data frames are distributed collection of data organized into rows and columns. Each column in the data frame has a name and associated data type. Data frames are similar to traditional database tables. Data frames can be created from various sources such as Hive tables, log tables, external tables, and existing RDDs. Data frame allows processing huge volume of data. PySpark is the Python API for Apache Spark. It enables you to perform real-time large-scale data processing in distributed environment. PySpark support all Spark features such as Spark SQL, data frame, structured streaming, machine learning, and Spark Core. That's the end of this introduction video. We will deep dive into each concept of PySpark in my upcoming video. Until then, thank you for watching.